Okay, party people, now that we're starting part 2, what do we remember from part 1? AI is not magic? Fantastic. The next model I want to discuss are decision trees. Decision trees can be simple or complex, but it's basically a way to try to predict what will happen based on other previous data and going from there. For example, you might try to predict what someone will do. In this example, Angry Bob gets news about the treasure. When Angry Bob gets that news, it depends on if it only affects Bob or if it affects the entire treasury. If it only affects Angry Bob, he may take one of two actions, such as malicious compliance or writing a strongly worded email. I kind of ran out of space, so the arrows are a little wonky. But let's say it affects the entire treasury. He may decide to notify the news, but if he doesn't notify the news, he may notify Agent Fluffbottom. And then from there, they will either go with Plan H or they may burn the treasury to the ground, depending on the situation. These can get very complex, and if you put a bunch of them together, you can create something called a random forest. Let's say we have a bunch of different decision trees and we've created a random forest. So now when we get our input of data, that data goes through different logic and equations of decision trees and creates our output. Let's say that there's an app where you can scroll through different videos. And let's say one of those decision trees is how long you stay watching videos with cats in them. That decision tree may decide, okay, we want to add more videos with cats. But let's say you get another video with like dogs in it and you like dogs, but not as much as you like cat videos. So it may put some dog videos in, but not as many videos as they would be putting in with cats. In other words, one piece of an algorithm. Okay, y'all still with me on this? So if AI is not magic, that means algorithms are not magic? Perfect, now you're on the trolley before we move on to the next one. The last one I'm going to discuss is neural networks, and obviously there are more data models than this, but I focused on the main ones that come up with the different logic that you might run into. When it comes to neural networks, think human brain. There's lots of different connections and synapses going on. So in this case, you might have your equations in logic 1, equations in logic 2, equations in logic 4, and like different nodes, and they all kind of talk to each other in different ways, and basically everything is all interconnected. This one might be more of a decision tree, this one might be more of like a simple yes or no, this might be categorization, but they're all supposed to work together. Putting everything all together and thinking about the different data models, all of that is going to interconnect within the second step. An example of this would be Deep Blue. It was programmed to play chess. So Deep Blue takes in all of this different input and data, and it runs through all this logic. And so it's looking at different things like strategies, game pieces, where the game pieces are currently, game layout, and it's piecing all of these things together to determine the most logical move to get to the end of the game. The goal being to win the game to get to a checkmate. So it's going through all of this different inputs and information that it has to determine the best course of action that will end with Deep Blue getting a checkmate and winning the game. In the next video, I'll discuss how the different logic and equations get refined and adjusted throughout the machine learning process. Okay, y'all still with me? I'm gonna say yes.